Hey, what is up, you guys? Guys, welcome to another episode on the Incredible Academics YouTube channel with the Incredible Academic himself. So, I just wanna. So today's topic is um, very simple, you guys, because we're gonna be looking at what we call double angles, right? Double angles. And what are double angles? Double angles are sort of like a subset of compound angles. Okay. Double angles, that is a special case. It's a special case of what? Of compound angle identities. Remember what I said? That with a compound angle, sine A plus Q, you can see that the assumption is that A and Q are not the same. But as soon as you say A is equal to Q, then we've got a special case of the double angle, which is what we call, so we're going to either have 2P, 2A, or 2Q, or the sine of 2Q. So this is a double angle, okay? It's a double angle. So it happens when the two angles are identical. Or you could have what? The cosine of A plus Q. And that would become what? That would become the cosine of 2A, or the cosine of 2Q. All right, and I want us to talk about when we're discussing the double angle identities, compound angle identity, we haven't really spoken much about what we call the tangent, right? We haven't spoken much about tangent of A plus Q, like any compound angle for tan, or any double angle for tan. And the reason is that this can be turned into what? Right? This can be turned into the sine of A plus Q divided by the cosine of A plus Q. And we're very much familiar with this and that. So you simplify the numerator and you simplify the denominator using the compound angle identities. So we never really speak much about tan compound angle identities, simply because we know you can use the identity for tan. All right, so it doesn't mean that this is not going to come in an exam or anything like that. No, it is going to come, but we're not going to discuss that as much, because we assume that you are smart enough, to figure out that, okay, there's this identity for tan, so I can always substitute the two and then I take it from there. Cool. So double angle identities. Now we're going to use because in grade 11 we never really spoke much about the identities for sine and cosine were coming from. Okay, not sine and cosine, but the double angles. We never really spoke about where these double angles are coming from. But today we're gonna delve deeper into that, so you guys can understand where the identities are coming from. But remember, the cosine of 2A is basically what? The cosine of A plus A, right? And we can now use the identity for the compound angle, right? The compound angle to expand this. So this becomes, with cosine, if there's a plus in the middle, here there's going to be a minus. So you need to figure out, okay, what's going to be the product here and what's going to be the product there. And it comes down to the question as to, are we going to have the same ratios here or different ratios? That is cosine. So cosine, cosine, sine, sine. So what are the angles that we need to plug in? It's just A throughout. So this becomes what? Cosine times cosine. There you have it. Okay, so this is the identity for what? This is the identity for the double angle for cosine. But remember, you can actually replace the cos squared, because remember we've got cos squared A plus sine squared A is equal to what? 1. You guys still remember the identity, right? So you can rearrange. You can either make sine squared A the subject of the formula or cos squared A the subject of the formula. Alright, so cos squared A is equal to 1 minus sine squared A. Also, sine squared A is equal to what? Sine squared A is equal to 1 minus cos squared A. So now you can see that if we can replace either cos squared A or sine squared A. So let's substitute. Let's replace cos squared A. So cos squared A is 1 minus sine squared A minus sine squared A, and then this becomes what? This becomes 1 minus 2 sine squared A. Alright, so this is another identity for what? For cos 2A. Right, another identity for cos 2A, 1 minus 2 sine squared A, cos squared A minus sine squared A. We've got 2 now. And then the third one, it's when we're replacing sine squared A instead of cos squared A. So now we're going to have cos squared A minus, what is the identity for sine squared A? 1 minus cos squared A. So we substitute 1 minus cos squared A. Then that becomes what? 2 cos squared A minus 1. Another identity. Okay, so we've got 3 identities for cos 2A. The first one is this, second one it's that, and this is the third one. All right, let's go right ahead and figure out what's going to be the identity for sine over 2A. Okay, sine of 2A, and we're going to do the same thing. We're going to say, okay, the sine of A plus A over there, and you do the expansion. We know very well if the middle sign there is plus, it's still going to be plus because we're dealing with the sine compound angle. All right, so now we need to figure out what's going to go over there and over there. Right, are the trig ratios here going to be the same or different? Because we're dealing with sine, it's going to be different. So we've got sine, we've got cosine, we've got sine again, we've got cosine. Okay, now we need to arrange the angles. A, and then this side we swap the order, but it's not going to make any difference. Right, but yeah. So there we have it. So this becomes what? This becomes sine. Okay, these are different, so it's not going to be squared, it's just going to remain like that. But you can see that these are exactly the same, so that becomes 2 sine A cos A. And this, ladies and gentlemen, is the identity for that, sine of 2A. So whenever you see the sine of 2A, you can replace it with this when you're trying to simplify identities. Okay, so we have covered the compound angle identities. So we're just going to do a couple of we've covered the double angle identities, not compound angle identities, although this is just a subtopic of compound angle identities. So let's look at a couple of identities and see if we can actually, utilize the compound angle double angle identities, put them into use. So sine x plus sine 2x divided by 1 plus the cosine of x plus the cosine of 2x. This is equal to the tangent of x. Okay. Remember, you're not allowed to move anything to the left or to the right. You just pick one side, focus on that, and show that it's equal to the other side. Okay. So normally we pick the side that is most complicated, and by the look of things, it's the left hand side. So let's simplify the left hand side. Okay. Luckily, there's only one identity for the sine of 2x. Okay, so we're just going to say, okay, sine x plus the sine of 2x, that's 2 sine x cos x. Okay, there's only one identity. And then 1 plus cos x plus what? Plus cos 2x. Now we need to figure out what's going to be the identity for cos 2x. Now we need to think, because with cos 2x the situation is a bit different, because it's got 3 identities. So meaning that you need to pick the right one. And I'm going to pick the one that's got -1. Why? Because I want this positive one to be gone. So 2 cos squared x minus 1. Then the -1 is going to cancel that 1 over there. Then it becomes easier for me to simplify. So you need to be thinking, right? Because when there's a positive 1 there, it's very difficult to factorize. This doesn't have any common factor. So, okay, sine x plus 2 sine x cos x. I hope you guys can already see what the common factor is going to be in the numerator. And then this one, the 1 and the -1, they cancel out, so we're left with cosine of x plus 2 cos squared x. You see, it's simplifying so beautifully. So in the numerator, common factor sine x out, 1 plus 2 cos x. In the denominator, cos x out, 1 plus 2 cos x. 1 plus 2 cos x cancels out. Isn't that beautiful? So this falls out. So we're left with what? Sine x over cos x. Alright, but this represents something. This is an identity for something. Alright, I hope you said the tangent of x, which is equal to the right hand side. So the proof is complete. Alright, indeed the left hand side is equal to what? The right hand side. Okay. So let's see if we cannot find. Sometimes you pick problems that are very complicated and you realize that your learners aren't really learning anything. They're lost. They're lost. So that's why I kind of avoid, solving problems that are, way too advanced, because the most important thing is for you guys to be able to relate to what I'm doing, to what I'm doing. And if you can relate what I'm doing when I'm solving the simpler problems, chances are that when we start, dealing with the most complicated problems, you guys will have a clue what's going on. Okay? All right. Anyway, let's start solving. And by the look of things, we need to focus on the left hand side. I don't know about you. You can focus on the right hand side. I'm focusing on the left. So 1 minus, there's only one identity for sine 2x. And that is what? That is 2 sine x cos x. Even if you say 2 cos x sine x, it's still the exact same thing, because remember, when multiplication is concerned, order doesn't matter. Okay, so now we've got a little bit of a problem. So this is what we have: 1 minus 2 sine x cos x. Most people would give up at this point. Okay, so the 1 in the numerator we cannot exactly factorize because there's no common factor. This is just the 1. So, I mean, it seems like the end of it. Right, but we can actually replace the 1 with sine squared x plus cos squared x, and then minus 2 sine x cos x. So we just replace this with a 1. Remember, this represents a 1. Then sine x minus cos x. Alright, so what do we do next? We just rearrange this. We rearrange the numerator, so there's sine squared x minus 2 sine x cos x plus cos squared x. Now this looks very much familiar. Over sine x minus cos x. This looks familiar. I mean, this has the form x squared minus xy plus y squared. Alright, it looks something like that. And how you factorize this, it's going to become x minus y, and then x plus y. I hope I'm right. I hope I'm right. But what I've written here to me seems like the difference of 2 squares. Okay, difference of 2 squares. So maybe this needs to be a minus. Alright, so let's see if we expand this one, if it's going to give us exactly that. Sometimes you just panic whereas your answers are correct, simply because you are not able to prove. So let's prove. This times this x squared, this times that minus xy, this times that minus xy, this times that plus y squared, minus and minus. Okay, so we've got x squared minus 2xy plus y squared. So we have got this. We have got this. So this becomes sine x minus cos x, sine x minus cos x. Alright, divided by what? Sine x minus cos x. And now there's something common there. This cancels with that. So we're left with what? Sine x minus cos x. And this is equal to the right hand side, isn't it? I believe so. It's equal to the right hand side. So the problem is done. Let's look for one more problem. And yes, one more problem. Aha, my battery's about to die. But anyway, if it cut me off, it's fine. So another problem is as follows: sine 3 theta over sine theta minus the cosine of 3 theta over the cosine of theta is equal to 2. Not so much battery, but look at the problem that we're dealing with now. Okay, left hand side. So the first thing that I suggest that we do is we get rid of the what we call we get rid of the, like we found the LCD, so we're just going to say the sine of 3 theta over sine theta times cos theta over cos theta. So we're just trying to find the LCD. Cos of 3 theta over cos theta times what? Sine theta over sine theta. Okay, so let's simplify. So that becomes, so now we can sum the two. So we've got cos theta sine 3 theta, right, minus sine theta, and then cos 3 theta, and this is all over sine theta cos theta. Okay, so now what we can do is we can then start to expand this into double angles. Okay, so we're going to say fine, we want to have cos theta into sine of 2 theta plus theta, okay, minus sine theta cos 2 theta plus theta. All right, still divided by sine theta cos theta. Cool, let's quickly expand our, if it goes off, you guys will definitely be able to complete this. I mean, the problem is almost done. Cos theta, so now in the denominator, I mean numerator, we've got sine 2 theta cos theta plus sine theta cos 2 theta minus sine theta, no, not enough space, so let's repeat that. So cos theta into sine 2 theta cos theta plus cos 2 theta sine theta, okay, and then minus sine theta into cos 2 theta cos theta minus sine 2 theta sine theta. Okay, so now we've got sine theta cos theta, so let's simplify. We multiply throughout here, so that becomes sine 2 theta cos squared theta, and then now this one we've got plus cos 2 theta sine theta cos theta, okay, and then minus cos 2 theta, and then cos 2 theta sine theta cos theta, and then lastly we've got minus sine 2 theta and sine squared theta, okay, all over sine theta cos theta. So let's see if, I mean, we can get rid of this by finding the common factor. All right, you can see that okay, sine 2 theta sine squared theta, we don't have a common factor for that. Yeah, we don't have a common factor for that. And then cos 2 theta, well, I mean, now is the time to actually, you know, observe and see what is common, what is not common, so that we can figure it out if we can find ourselves a common factor. But by the look of things, there isn't like a complete common factor. All right, but let's check. Cos 2 theta sine theta cos theta. Can you see? I mean, the two are exactly the same. Okay, so we can cancel them out. Cos 2 theta, sin theta, cos theta. So we can cancel them out. So basically what we're going to be left with is sin 2 theta, cos square theta, and then minus sin 2 theta, sine square theta. And there's something beautiful about this because it seems like there's a common factor, right? Sine 2 theta, sine 2 theta. So we take that out. Let's take that out, sine 2 theta. So if we take out sine 2 theta out, we're left with cos squared theta minus what? Sine squared theta. And we know the identity for that. Okay, we know the identity for that. So this is divided by what? This is divided by sine theta cos theta, right? Cool. So in place of that, we're just going to substitute what we call cos 2 theta. Right, hopefully we're gonna find the right hand side. Yes, so this is what we have: sine 2 theta, cos 2 theta divided by what? Divided by, remember what we have in the denominator, which is sine theta cosine of theta. This we can rewrite. Remember, this is the situation. Sine 2 theta is equal to 2 times sine theta cos theta. Alright, so meaning that sine 2 theta over 2 is actually equal to what? Sine theta cos theta. All right, so now we can replace this with that. Okay, so meaning that now we're going to have sine 2 theta cos 2 theta divided by what? By 1 over 2 sine 2 theta. So this is going to cancel with that, right? And then we're going to have 2 the cosine of 2 theta, right? And this is supposed to be equal to the right hand side, but unfortunately on the right hand side we only got what? We only got 2 sine 3 theta minus cos, yes, we only got 2. So we probably made a mistake somewhere. Okay, we probably made a mistake somewhere, but I'll double check and see what happened. But I mean, you guys got the idea. You know, this is how you simplify. It's not about getting the answers correct. Okay, it's about, because with these type of problems you find that the final answer is actually worth just 1 mark. So it's about you understanding what to do and when. That's the most important thing. And ladies and gentlemen, we've come to the end of the lesson, and I hope you guys learned a lot. Don't forget to like, subscribe, comment, and tell friends and family about the channel. Let's go.